Hello everyone. In the previous class, we have discussed about the definition of differentiation and what is the basic formula to find a derivative of some continuous function y with respect to x. As the function y equal to f of x, in this x is the independent variable and y is the dependent variable, and here y is depending on the variable x. Whenever the value of x changes, the value of y will get changes. So that is the meaning of dependent and independent variable. On the basis of this curve, we have derived the basic formula to find the derivative of some function y, and the formula is dy by dx equal to limit as h tending to 0 f of x plus h minus f of x divided by h. And here this h refers to the increment in x value, right? Whenever we are using this formula and finding the derivative of some continuous function y, we call that method as first principle method. You can refer the previous video so that you will definitely find easy way to use this method and the definition of differentiation. So today let us solve one problem by using this method. Okay, let us have one function y as x raised to n. So you can notice here x raised to n is the function. Directly we can call this as a polynomial, right, which is a function of x. You can write f of x here. So using this rule, we need to find the derivative of x raised to n. So by first principle method, we'll find out the derivative of y with respect to x. Let f of x equal to x raised to n. Then f of x plus h will be, in the place of x, we have x plus h, right? So this will be x plus h whole raised to n. Then, according to the formula, f of x plus h minus f of x divided by h is there as limit h tending to 0. Let us put this in the formula. Dy by dx will be equal to limit as h tending to 0. F of x plus h is nothing but, here this formula, f of x plus h is nothing but x plus h whole raised to n, and f of x value is x raised to n divided by h is there, right? So this is the formula. Now we need to simplify this. To simplify this, we have binomial theorem expansion here as two variables x plus y, x plus h, a plus b, whatever you have used in your previous classes. Okay, the variables. I am considering x plus h here because we are having x plus h whole raised to n, right? So that's why x plus h whole raised to n is equal to nc0 x raised to n, nc1 x raised to n minus 1 into h plus nc2 x raised to n minus 2 h square, so on up to ncn h raised to n. This is the expansion, binomial expansion, right? Whatever be the term, the whole term will have the power raised to n, power n. So this is the binomial theorem. I am using this expansion to solve the problem. Okay, so this will be nc0 is nothing but 1, so x raised to n plus nc1 is nothing but n, so x raised to n minus 1 h. nc2 is nothing but n into n minus 1 divided by 2 factorial x raised to n minus 2 h square, and so on up to ncn, which is also nothing but 1 h raised to n we left, right? So let us use this formula. What we are having, dy by dx is equal to limit as h tending to 0 x plus h whole raised to n minus x raised to n divided by h, right? So this will be, see here, limit as h tending to 0, x plus h whole raised to n. In the place of this, we need to write all these terms. Minus x raised to n is there. So minus x raised to n plus x raised to n. These two terms will get cancelled together. We left with n into x raised to n minus 1 into h plus n into n minus 1 divided by 2 factorial x raised to n minus 2 h square, and so on up to h raised to n is there, right? Whole divided by h. This x raised to n and this x raised to n will get cancels together. So I left the term and write it down. Now we'll take h common. Okay, because whenever you take the value of h outside, this h and this h will cancels together. Now we left with n into x raised to n minus 1. Okay, I will write it down. Limit as h tending to 0, n into x raised to n minus 1 plus n into n minus 1 divided by 2 factorial x raised to n minus 2. 1h we have taken outside, we left with 1h here, and so on up to here 1h we have taken outside, we left with h raised to n minus 1. Whenever h tending to 0, so this h will get the value 0. 0 into some term also will get 0, and up to all the terms, last term will get the value h as 0, so the term will become 0. Whenever the term free of h, that will left, that is n into x raised to n minus 1. So this is the value of derivative of x raised to n with respect to x. dy by dx is n into x raised to n minus 1, which is very important formula to keep this in your mind. Okay, let us meet with one more problem in the next class.